Students, welcome to today's class. The details of this course are course code Math 921, course title Numerical Analysis and Computation 2, topic Least Square Approximation Method. Introduction. Sometimes we may be faced with finding a solution to a problem that represents a set of data points which are given for both argument x and y. It may be difficult to find such a function y, which except by certain techniques. One of such techniques is least square method. The idea about least square method has to do with fitting polynomial functions into a set of data points. Least square approximation method. The basic idea of least square approximation method is to fit a polynomial function px to a set of data points fx, yi, having a theoretical solution as y is equal to f of x. The aim is to minimize the squares of the errors in order to minimize the squares of the errors in order to find a solution to that set of data points. The difference obtained from the course, be it negative or positive, and when all these are summed up, the sum may add up to 0. This will not give a true error of the approximation of the approximated polynomials. Thus, the estimate of exact error sum, the square of this difference, are more approximate. In other words, we usually consider the sum of squares of the deviations to get the fitted curve. What we are trying to say here is that the major idea about least square approximation method is how to fit a polynomial function into a set of data points that may be given for both argument x and y. Once that data is gotten in a tabular form, you now get the deviation, that is the difference between the actual value and that of the fitted equation. The squares of the sum of the deviation is what we refer to as least squares. So the smallest between the two is the least squares of the two. Least square approximation method could be divided into two. We have discrete and continuous least square. In the discrete least square approximation method, we fit a polynomial functions by deriving the formula in a discrete form that fits a set of data points by least square method. The aim of least square method is to minimize the error of squares involved. Solving equation to determine A1, A2, and A3 in a step form. Example 1. By using the least square approximation method, fit a straight line B, a parabola, to a given data. We have x 1, 2, 3 up to 6. We have values of y, associated values of y, 80, 60, 40, 50, 20, and solving this, we now use the two equations. Summation y1 equals to na0 plus a2 summation xi. The second one is summation xyi is equal to a0 summation x plus a1 summation x raised to power 2. Using the table below, you can now form equation with the data above. The equation formed is seen below. This is a simultaneous equation that can be solved simultaneously. Solving it simultaneously gave us the following values: a0 to be 89.33, a1 to be minus 13.14. Therefore, the straight line fitted in the given data is y is equals to 89.33 minus 13.14x. Getting the second one, we can now use the three equations. From there, we can now tabulate the values of x, y, x squared, x raised to power 3, x raised to power 4, xy, and x squared y. You can see the tabulated figures there for that set of data points. Substituting it in the above equation will give us the three equations. Solving these three equations simultaneously by the use of a matrix method gave us the values below. a0 to be equal to 91, a1 to be equal to minus 14.39, a2 to be equal to 0.18. Now, the straight line fitted to the given data above is given by the equation below. Y is equals to 91 minus 14.39x plus 0.18 x squared. We now use those two equations to fill the table below. Using this table below, you can now see the difference between the equation fitted by the straight line and the equation fitted by the parabola. So you can now see the values there, the sum of squares for both parabolic function and the straight line function. The total sum of squares of parabolic function is 309.28, while that of the total squares of linear function gave us 310.48. You can now see that the parabolic function has a lesser value. So we conclude this. The sum of squares of the errors of fitted line by linear function y of l and quadratic function y of q are shown above. The comment here is that the sum of squares of errors of the linear function 310.48 is slightly greater than that of the quadratic function 309.28. Invariably, the quadratic function is a better approximation. Thank you and remain blessed.